Hello, so this will be lesson 3 of our Java journey I'm taking you on. In this lecture or lesson, whatever you want to call it, I'm going to take you through primitive data types. We're going to go through some simple arithmetic with them and just how they work in Java, what the syntax is, how you declare them, everything you would need to know about basic numbers, Boolean, true or false, double, everything like that. We're going to go through it right now. Okay, so, well, like we did last time, if you haven't watched our video, I would recommend going and watching it. But if you want to continue from here, all we're going to do here is we're on replit.com. And what you're going to do is create a new REPL. So you're going to click Create REPL. And your templates, you're going to go Java. And then you can name it primitive data type practice. We'll do Create REPL. And it's going to give us our Java file, and beautiful. So again, we're just going to delete everything here. We're not going to need this, and we're going to delete this at the bottom here. So make sure your code looks something like this for now. And even this line right here, the system.hello world, we're going to get rid of. Okay, so there's a few different things you can declare in Java. And one of the most common ones you're going to run across is the integer. Like the integers in math, it's very similar, and you declare it like this. You type int, and that you always have to have this. Is going to give us some recommendations. We're going to ignore those for now. So putting int here is going to give you the option to put some sort of variable name, and then you're going to be able to assign a value either now or later. So what we're going to do here is we're going to give it the name integer. And keep in mind, you cannot name it int, of course. It's a keyword, so let's name something like integer. And we're going to assign it a value. So that when you're assigning a value, it's very much like math. You're saying it equals to, let's say, 5. And then at the end of it, you have to put before a semicolon. And now you have this integer 5 that you have declared. And so what we're going to do is we're going to do some arithmetic. Or let's run the code first and see what comes out of the console. So you can take your assumption, take a guess of what you think is going to come out. And if we take a look, we will see nothing comes out of the console. And did we do something wrong? Absolutely not. This is just how it works. It's not going to print to the console automatically. If you want it to come out, you have to do like last lesson we did. It was system.out.println, and you put whatever you want to print out. But we'll go over printing variables later in this video. So first, what I'm going to do is let's declare a second one. So we're going to do int, and we're going to call this integer 2, and we're going to give this a number 4. So this is equal to 4. And another way we could have even declared this is if we went like this. So this is just saying integer with the name of integer 2, and then we can later go down, and we don't have to put int anymore. So we can just go integer 2 equals 7, for example, and this is completely valid. And it's giving us some error, but this, you can ignore this. REPL does have some issues where it does stuff like this, but nothing we need to worry about. So now we have our integer 2 is assigned a value, and what we're going to do is we're going to try to do some arithmetic with them. So what we're going to try to do is we're going to go, let's create a third one up here, and we're going to go int, and we'll call it sum. And what we're going to do is we're going to go down here, and we're going to say it's very much like math. Sum is equal to integer. It's going to try to give us an auto recommendation plus integer 2. And now the sum is going to be here. And how can we confirm this? We're going to do like we did last time. System.out.println, and we're going to put round brackets. We're going to type sum, and we're going to go semicolon. Now you have your print line, and we'll be able to see the result. So we know integer is 5, integer 2 is 7, and when you sum together, we're hoping that it's going to be 12. So let's run it, and if it's 12, we have done it correctly. And right there, boom, it says 12. So this is absolutely correct. So what other operations can you do? Well, any operations you could do on any number, you could do here. So we're going to try, let's make another one, or we can even change this from int sum to product. And so product, what we're going to do is we're going to get rid of this. And when you want to do multiplication, what you're going to do is you're going to put a little star here. And when you put the star, it's asterisk, you can then run it, and it's going to print 5 times 7, which is going to give you 35. So let's see that output. And oops, I forgot. Again, you have to change it everywhere if we're changing a variable name. So the product is equal to the integer times integer 2. Now this should give 35. What am I doing here? Again, see, everyone can make mistakes here. This should be product again. So remember, if you're changing your variable name, you have to change it everywhere. And now this hopefully will give us 35. And it does. It gives us 35. So you can do any basic arithmetic you want to do. And there's some properties about each one. So I'm going to go through a quick property of the integers. So when you integer, now the next thing you would want to do is, of course, subtraction. So we do subtraction, which is going to follow the same. You're going to put a negative sign. Not very interesting. Let's even do, we won't change the variable name, but 5 minus 7, as you would expect, negative 2. Not very interesting. But the thing that would be interesting is we want to see division. So we can do, let's call it result so we don't have to keep changing it. And we're going to call this one result. And result is going to be integer divided by integer 2, and we're going to print result here. So you can take your guess at how you think it's going to output, and we'll see what it does. So this gave 0, which is very interesting because we know 5 divided by 7 is not actually equal to 0. So why is it outputting this? Well, this is because integers are whole numbers, and because we're storing the result as an integer, it's going to come out again as a whole number. So this is where you might be like, what if I need a decimal number? That is where you're going to come and use something called a double. And double is because it's double precision. So double precision, double floating point. It basically, IEEE has some standards of how can we represent decimal numbers, which are all Java and everything, all computers, they only understand ones and zeros. So everything that you give it, it's going to eventually convert to a 0 or 1. And so they have to find a way, how can we represent decimals that go on forever? And so they have this certain method that they like to do that keeps it so it's only up to a certain decimal point and a certain amount of precision. This is double precision, double floating point. So what we're going to do is double, and we're going to call it double, or we can even do result here. And so let's call our result, let's call it result 2, because 2 variables cannot have the same name in Java. There's some cases, but for now, not important. We're just looking at this. Result 2, double result 2. And what we're going to do is result 2 is equal to integer divided by integer 2. And we're going to print that out. We'll see what comes out. Oops, we are missing semicolon. Let's go again. And it's going to give 0.0, which is, again, we thought we had double. Why is this not working out? Well, again, you're dividing two integers, so the integer arithmetic is going through, not the double. If you really wanted this to do that, what you would do is here, you would change this to double, and let's call it num1, and we'll change this other one to double num2. And here we're going to go num2 is equal to 7, and we're going to do num1 divided by num2, and we're going to see what comes out. And now you can see you have a decimal representation. Instead of having your 0.0, you have a useful value you could get here. And this is very useful. So now we know there's a whole other type of primitive data type. These are all called because they are stored not with references or pointers. They are stored directly where you put them. We'll get into all that later. But there you go. This is a very useful tool if you want to have decimal numbers in your code for whatever reason. And there's a lot of different things you could do. So we could even go with there's different forms. So we can actually have something called a Boolean. So a Boolean completely leaves our idea of numbers, and we're going to call it, let's say, bool. We'll call it that for now, and that'll be its result. So Boolean can have a couple different results. It can either be true, it can be false, or it can be null. And null means it has nothing, which is not very useful for us. We're going to start it off as true. And let's print out bool and see what happens. So we print out bool here. And it's going to show it's true. If we change it, let's say to false, it'll show us false. And these are great for whenever you have code and you want to have some sort of condition. You want to say, well, when this is true, I want this to happen. When this is false, I want this to stop. When you're doing loops, if statements, Boolean variables are extremely useful for when you're using truth and stuff like that. You're dealing with anything of whether it's true or false, where something's a yes or a no. And so very useful. So the next thing I'm going to go through is, well, we have char. And this is another primitive data type, and this allows you to store, we're going to call this one character. And as you're going to assume, this one's going to let you store a single character. It can be any ASCII character, so it can be hashtag, it can be G, it can be 4, it can be uppercase H, it can be anything. Anything you have on your keyboard, you could put here, most likely, unless you're using some sort of really weird keyboard. Anything else, 100% going to be put here. And so we're still printing bool, so why don't we change this to print out character, and let's see what happens. And we see there you have a character H. And so this is how you store individual letters. When would this be useful? Well, there's a lot of times where you might be running a code where you want to look at an individual letter, maybe in a string, and what you're going to do is you're going to have it stored as a char, because that's the best way to do it. And all of these are low level, very, very easily converted to numbers going to binary. So these are your very, very fast, no reference to anything, quickly accessible variables. So if you can get very comfortable with these, you're gonna have a very good time when we're moving on to higher level sort of strings and when you're making your own classes. And so I'll show you even a couple things you could do with these. You can do with a Boolean variable. So let's say you have it set to false. Can this ever be set to true again? And the answer is yes. You can go Boolean equals bool equals true. And now, if you print out bool, and it's going to give you true. Even though we initialize it to false, its newest value before we print is going to give true. And so it might seem kind of arbitrary what we're doing right now, but this is just laying the foundation. I just want you to understand that integer store a whole number, positive or negative, like the real integers. Double is when you want your decimal numbers. A Boolean is a true or false value. A char is a character. It can be any character you want, even can be a number, but be careful. It does not operate the same way an integer or a double does. And so you have to be very careful when you're storing these, and you need to know what they are all doing specifically, and know what cases you're using them. Of course, you ever need a single character, you can use a char. If you ever need a true or false value, you can use a Boolean. If you ever need a decimal number for some sort of precision calculation, you're going to do a double. And if you just need a integer, you're going to use, of course, int. And so, like, we have 7 here, but this 7 is different than this 7, which is an integer. And if we decide to say, let's say we want to add a character, which is 7, to num2, that won't work. And we'll see. This is type double, and this is type character. And we're going to see what happens when you run this code. And so, it will give you a number. But if we look at it, 7 plus 7 is not 62. So what's happening is because every ASCII character is assigned a number. So this is why you have to be very careful. You cannot treat this like a number. You cannot treat this like 7 is the number. It is an ASCII character. It is assigned some number to identify it. you have to be very careful. Java will let you do this, and look, you can get away with doing it. The code will not crash, but it is not something you want to try to do. Some combinations of these are very useful. So if we go to our um, num2, which is 7, let's do num2 plus our, and we're going to make a new double. We'll call our new double just d, or db for double, and we're going to let it be equal to 3.5, and we're going to try to add it to our integer. Will this work? Will this give us a meaningful value? And 3.5 plus 7, we're hoping for 10.5. Let's see what it gives us. And it does give us 10.5. So you can add these ones safely and it will work. Of course, it's better if you're working with doubles to make sure they're all doubles. If you're working with integers, make sure they're all integers, because you're going to have some issues with precision. And when you're trying to add a lot of double values together, or a lot of integer values together, and you have a double there, maybe your code can only handle whole numbers, and then you're dealing with numbers that are a bit over and under, which is not going to be ideal for your code. But if there's a case where you can do this safely, it absolutely will run, unlike adding a character to a double, or to anything for that matter. And so I think that's going to wrap us up for this lesson, and we're going to get more into actually methods and stuff like that in future videos. This is just going to be very baseline. If you understand stuff very well, you can probably skip the next couple videos before we get into methods, conditionals, loops, and everything like that. That is going to be a lot more useful. But I wanted this to be bare minimum. You don't know anything about programming, going through it. I hope this was helpful, and thank you for watching this video. Have a great one.